Here's problem 1327. Planet 0 has a mass of 5 times 10 to the 23 kilograms and a radius of 2 times 10 to the 6 meters. A space probe is launched vertically from the surface of 0 with an initial speed of 4,000 meters per second. What is the speed of the probe when it is 3 times 10 to the 6 meters from 0's center? So here's planet 0, and it's got a certain radius, which we'll call R1 because that's going to be our initial position, and then we are going to achieve a final position, let's call it R2, which will achieve that height, but we won't be in a stable orbit, so we're just simply going from one height to the next height. So it's kind of a launch here to this second height, and hence we are going to have conservation of energy. Our initial energy will equal our final energy. That means our initial kinetic energy plus our initial potential energy will equal our final kinetic energy plus our final potential energy. And we have then that 1/2 mass times our initial velocity squared as we launch, plus our gravitational potential energy, which is a negative gm little m over the distance between these masses, which would be r1. It's not a stable orbit, so it's simply stationary gravitational binding. That's going to equal 1/2 mass times our final velocity squared plus, and then again we just have stationary binding at that point, negative g m over r2. We have an m term in each of these, so let's divide both sides of the equals by m, and we're going to solve this for our final velocity. Let's bring over the negative g m over r2 to the left hand side, so we have 1/2 initial velocity plus gm over r2 minus gm over r1 is equal to 1/2 final velocity squared. Multiply both sides by 2, take the square root, so our final velocity is going to equal our initial velocity squared plus 2 times gm 1 over r2 minus 1 over r1. All this square root. So this is going to equal 4,000 squared plus 2 times 6.67 times 10 to the minus 11 times the mass of the planet, 5 times 10 to the 23, 1 over 2 times 10 to the 6. I'm going to do this. No, 1 over 3 times 10 to the 6. Minus 1 over 2 times 10 to the 6. All this square root. And that is equal to 2,209.8 meters per second. So that's our final velocity in meters per second, 2,209.8 or 2.2 kilometers per second. We started with a launch velocity of 4 kilometers per second, and now we're down to 2.21 kilometers per second at this new radius.